Hello, welcome to 2.2 Basic Differentiation Rules and Rates of Change. And as we saw in the last section, we had to do a lot of algebra, a lot of work to get us to the answer. Now we'll get to use some rules that we can maybe see patterns from what happened in that. Use these shortcut rules. And it's important to understand the process. So I do stand by that we did need to cover 2.1. People always say, well, why do we cover that? Why don't we just learn the shortcuts? Well, because you're learning the breadth, the depth of what's happening with this calculus, not just how to apply it. So here we go. The constant rule. If c is a constant, then the derivative with respect to x of c is 0. When you take the derivative of a constant, it's always going to be 0. So find the derivative of each of the following. dy dx of 5. Well, dy dx is just going to be the derivative with respect to x of 5, which is 0. Here, f prime of x is just going to be 0. And g prime of t is going to be 0 because these are all constants. Now, I say almost the funnest one to learn, if I can say funnest, not even proper grammar, is the power rule. If n is a rational number, then the function f of x equals x to the n is a differentiable function. Okay, we're good there. The derivative with respect to x of x to the n, here it is, drum roll please, I'm going to feel the ground shake, is n x to the n minus 1. That power comes out front and you subtract 1 from the power. That's what you do when you take the derivative of a variable raised to a power, a constant power. So for f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 is defined on the open interval containing 0. So we're going to do some examples. We're going to find the derivative of each of these. First of all, f prime of x. Well, f of x is x to the 4, so f prime of x, that 4 is going to come out front. 4x to the 4 minus 1 is 4x to the third power. Now this is g of x. Think of that as x to the 1/4 power. So g prime of x is going to be x, well, the 1/4 comes out front to the times x to the 1/4 minus 1. That's 1/4 x to the negative 3/4, which would become 1 over 4x to the 3/4. So these two answers are acceptable. And then y equals 1 over x. This is like saying y equals x to the negative 1. So our dy dx is going to be the derivative with respect to x of x to the negative 1. That power comes out front. Negative 1 times x to the negative 1 minus 1. Negative 1 times x to the negative 2, or negative 1 over x squared. Okay, for example 3, it says find the slope of the graph of f of x equals x cubed at x equals negative 1, x equals 0, x equals 1. So the first thing to do is say, okay, well, f prime of x would be 3x to the 3 minus 1, or 3x squared. So f prime at negative 1, putting negative 1 in here, is going to be 3 times negative 1 squared, which is 3. F prime at 0 is going to be 3 times 0 squared, which is 0. F prime at 1 is going to be 3 times 1 squared, which is 3. Now the original function had this kind of a graph. And what we're seeing then is at negative 1 and at, sorry, negative 1 here, positive 1 there, the slopes are the same. However, at 0, the slope is 0. ahead and pause if you need some more time. I'm going to go on. Now we're going to find the equation of the graph of the tangent line of f of x equals x cubed at x equals negative 2. So as we saw in the previous problem, f prime of x was 3x squared. So f prime at negative 2 is going to be 3 times negative 2 squared, or 3 times 4, which is 12. And that's our slope. So we do y minus, what's the point we get from, what is f of negative 2? That's negative 2 cubed, which is 8. So the point is going to be negative 2, 8, and the slope is 12. So y minus 8 equals 12 times x minus negative 2. Y minus 8 equals 12 times x plus 2. Y minus 8 equals 12x plus 24. So y equals 12x plus 32. Oh, there's a mistake. There should have been a negative 8 here. Negative there makes that plus. So we subtract the 8. That should have been a 16. Sorry about that. Okay, the constant multiple rule. If f is a differentiable function and c is a real number, then c times f, can't really see that, is also a differentiable function, and the derivative with respect to x of c times f of x is c times the derivative. So the constant, just you could factor that out, is multiply it by the final result. Okay, we have several little problems here on example 5. It says use the constant multiple rule to find the derivative. Y equals 3 over x. Think of this as 3 times 1 over x. So our dy dx is going to be the derivative with respect to x of 3 times 1 over x. That's going to be the derivative with respect to x of 3 times x to the negative 1. That's going to be 3 times negative 1 x to the negative 2, because 1 minus 1 is negative 2. That's negative 3 over x squared. F of t equals 3t cubed over 5. Think of this as 3/5 t cubed. So f prime of t is going to be 3/5 times the derivative of t cubed is going to be 3t squared. So it's going to be 9t squared over 5. Y equals 4 times the cube root of x. Think of that as 4 times x to the 1/3. So dy dx is going to be the derivative with respect to x of 4x to the 1/3. That's going to be 4 times 1/3, x to the 1/3 minus 1. That's going to be 4/3 x to the negative 2/3, which is 4 over 3x to the 2/3. And I guess if you want to go a step further, it'd be 4 over 3 times the cube root of x squared. I take any of these three. Next one, we have y equals 1 over 3 times the 4th root of x cubed. Think of that as 1 over 3 times 1 over the 4th root of x cubed. Think of that as 1 over 3 times x to the negative 3/4. So that our y prime, let's go to y prime now, it's going to be 1/3 times this power, negative 3/4 times x to the negative 3/4 minus 1. Well, the negative 3 and the 3 would cancel, leaves a negative 1 up top. That's going to be negative 1/4 x to the negative, this is 3/4 minus 1, negative 3/4 minus 1. I think that's 4/4, so negative 7/4. negative 1 over 4 times the 4th root of x to the 7th. And I would take this answer as well. And for e, y equals negative 5/3 x. Think of that as negative 5/3 times x. So y prime would be negative 5/3 times x to the 1 minus 1. It's negative 5/3 times x to the 0, which is negative 5/3, times 1, which is negative 5/3. Probably one of the easiest ones, and I drag it out as long as possible. When you have a linear term, its derivative is just going to be a constant, which is 1, or the coefficient in this case. Okay, feel free to pause that one. I'm going to go on to the next page. It says using parentheses when differentiating. So here we have y equals 4 over 3x squared. I'd rewrite that as 4/3 x to the negative 2. So when you differentiate, you have 4/3 times negative 2 x to the negative 3. Subtracting 1 from that power makes negative 3. So this is negative 8/3 x to the negative 3, or negative 8 over 3x cubed. Now we have y equals 4 over 3x quantity squared in the denominator. Okay, let's try and get this cursor out of the way. This would become 4 over 9x squared. So this is, rewriting this is 4/9 x to the negative 2. That's going to be 4/9 times negative 2 x to the negative 3, or negative 8/9 x to the negative 3, which is negative 8 over 9x cubed. I'd take this one too. Now we have y equals 5 over 2x to the negative 3. You think of this as 5 over 2 times 1 over x to the negative 3. That's 5/2 x cubed. So the derivative is going to be 5/2 times 3x to the 2. Subtracting 1 from 3, we get 2. This should be 5/2. And so from this we get 15/2 x squared. Here we have y equals 5 over 2x to the negative 3. This negative power is going to bring it up. That becomes 2x to the 3rd power, which is 5 times 2 cubed is 8x cubed, or 40x cubed. So the derivative is going to be 40 times 3x squared, or 120x squared. Okay, moving on, so pause if you need to pause. Sum and difference rules. The sum or difference of two differentiable functions is differentiable, and it's the sum or difference of their derivatives. So the derivative of this sum would be the sum of their derivatives. The derivative of the difference is the difference of their derivatives. So find the derivatives. Here we have f of x equals x squared minus 4 over x cubed. Think of this as x squared minus 4x to the negative 3. So f prime of x is going to be 2x minus 4 times negative 3x to the negative 4. So subtracting 1 from negative 3, you get negative 4. So f prime of x is going to be 2x. And by the way, the 2x, the 2 comes out front. 2 minus 1 is 1 for the power. Plus 12 over x to the 4th power. For b, f of x equals the square root of x minus 6 times the cube root of x. Think of this as x to the 1/2 minus 6 times x to the 1/3. So that f prime of x is going to be 1/2 x to the negative 1/2 minus 6 times 1/3 x to the 1/3 minus 1 is negative 2/3. This is going to be 1 over 2 times x to the 1/2. 6 and the 3 cancel, leaves a 2. So then minus 2 over x to the 2/3. That's 1 over 2 times the square root of x minus 2 over the cube root of x squared. Okay, I'm going to go on to the next page. The derivative of sine and cosine, I think these would be a little more of a challenge to derive. One way to derive them is after we define like a power series, which you get in calculus 2, you can work this out to come up with these results. Anyway, the derivative with respect to x of sine x is cosine, and the derivative with respect to x of cosine x is negative sine. So the derivative of sine is positive cosine, derivative of cosine is negative sine. So find the derivative of the functions. Y equals 3x, 3 sine x. Well, the derivative of sine is cosine, so it's 3 cosine x. For b, y equals cosine x over 2. That would be like 1/2 cosine x. So y prime would be 1/2 times negative sine x, because the derivative of cosine is negative sine. It's negative 1/2 sine x. And if we have y equals x plus sine x, y prime would be 1, because the derivative of x is 1, plus cosine x, because the derivative of sine is cosine. Okay, moving on. Down to rates of change. As we have used derivatives to determine slope, we can also use derivatives to determine the rate of change of one variable with respect to another. Some examples of applications: population growth, production rates, water flow, velocity, and acceleration. So we'll discuss the rates of change of an object moving in a straight line. How is it moving? Is it going fast, slow? Is it going to the right, going to the left? What's happening? So we use s to describe the position function s of t. S typically describes position. The average velocity is delta s over delta t, which is the change of position with respect to the change in time. So for example 9, it says s of t equals negative 16t squared plus 50. Describes the position of a rock being dropped from 50 feet. Find the average velocity over the given intervals. So in the first case, we have s of 2 minus s of 1 over 2 minus 1. Now s of 2, that's 2 squared is 4. Negative 16 times 4 is negative 64, plus 50 is negative 14, minus 1 squared is 1, so negative 16 times 1 is 1. It says 16, excuse me, negative. Plus 50, that's going to be 34 over 1. So negative 14 minus 34 is negative 48 over 1. So negative 48 feet per second would be our velocity there. For B, we have s of 1.5 minus s of 1 over 1.5 minus 1. That's 0.5 down below. Now s of 1.5 squared is 2.25, and then negative 16 times that plus the 50 is going to give us positive 14 minus 34 over 0.5. That's going to be negative 20 over 0.5, and that's going to be negative 40 feet per second. The third case, it's s of 1.1 minus s of 1 over 1.1 minus 1. 1.1 minus 1 is 0.1 down below. Now s of 1.1 into t squared, 1.1 squared is 1.21 times negative 16 plus 50. That's going to give us 30.64 minus the 34. So we're looking at negative 3.36 over 0.1, which is negative 33.6 feet per second. We can see this becoming smaller and smaller, and we eventually have the limit go into a specific value. So, question. This would be the average velocity over the given intervals. What do you think the velocity is after 1 second? Well, velocity is the derivative of position. So what is the derivative of negative 16t squared plus 50? That's going to be negative 16 times 2 times t. And derivative of 50 is 0, so that's going to be negative 32t. So velocity after 1 second is s prime at 1, which is going to be negative 32 times 1, which is negative 32. So we're getting close to that. We're getting close to negative 32. Okay, let's go on to the last page here. Kind of let the cat out of the bag, but here we go. Instantaneous velocity v is the limit as delta t goes to 0 of s of t plus delta t minus s of t over delta t. That's s prime of t. So the speed of an object is the absolute value of the velocity. So velocity could be negative, but speed is the absolute value. So here's our generic position function. S of t is 1/2 g times t squared, where g is your acceleration due to gravity usually, plus v naught t plus s naught. A projectile is shot upward from the surface of the Earth with an initial velocity of 120 meters per second. What is its velocity after 5 seconds and after 10 seconds? Use s of t equals negative 4.9 t squared plus v naught t plus s naught. So s of t is negative 4.9 t squared plus our initial velocity is 120 meters per second plus 120 t plus 0 because we're on the surface. So velocity at time t is going to be s prime of t. This is negative 4.9 times 2 times t to the 1 plus 120 times t to the 0. So our velocity, which is s prime of t, is going to be negative 9.8 t plus 120. So our velocity at time 5 is negative 9.8 times 5 plus 120, and that's going to be 71 meters per second. And the velocity at time 10 is going to be negative 9.8 times 10 plus 120, which is 22 meters per second. Okay. And that'll do it for 2.2, basic differentiation rules and rates of change. Thank you, and send me your questions. Bye.